Waves interact with matter. As waves move through space or matter, they continue in a straight line until they come into contact with a different medium, which changes their motion. There are different ways that a wave can behave after this interaction, but we're going to focus on the three main ones: reflection, absorption, and transmission. A wave is reflected when it encounters a substance that acts as a barrier. Light that is fully reflected will bounce off of the substance and back into your eyes. This is what happens when you look in a mirror. Your image is reflected back. That happens because light has reflected off of the mirror and back into your eyes. This is also how we are able to see the moon. The sun's light reflects off of the moon's surface and into our eyes on Earth. A wave is absorbed when it hits a substance and causes the molecules of that substance to vibrate and move. This causes energy to be transferred away from the wave because it has been absorbed by the substance. Light that is fully absorbed will transform into another form of energy, usually thermal energy, which we feel as heat. The more an object's molecules move and vibrate, the hotter it becomes. This is why black objects become hotter than lighter objects. Black objects absorb all light waves and convert them into thermal energy. Finally, light is transmitted when it moves through a substance. Transparent materials, such as glass, transmit light. This is why you can see through them. How light behaves depends on the medium with which it is interacting. Some materials are more reflective or absorptive than others. It is because of this that we see the world in the colors that we do. A small band of electromagnetic spectrum is made up of visible light. Visible light is all of the light waves our eyes can see. Each color is determined by its specific frequency and wavelength. Color of an object. An object's color is not within the object itself. Instead, the color of an object is determined by how that object interacts with light and then reflects, absorbs, or transmits it. When visible light hits an object, different frequencies are absorbed and reflected. For example, a strawberry is red because it absorbs all of the frequencies of visible light that shine on it except for the frequency associated with red. Black and white are not actually colors because they don't have a specific wavelength. Black objects absorb all wavelengths of light and convert them into heat. In contrast, white objects reflect all wavelengths of light. As waves interact with matter, their properties can change. For example, as light moves from one medium to another, the wave can become bent. This is called refraction. Refraction occurs because light travels more slowly in air than it does in the vacuum of space. It moves even more slowly in water than it does in air. When a wave is refracted, its speed changes, as does its wavelength. However, its frequency remains the same. Refraction is what happens when you look at an object that is partly in water and partly in air. The object appears bent at the water's surface because light waves are bending at the boundary between the air medium and the water medium. Rainbows. Rainbows are a result of light being refracted and then reflected by water droplets. Rainbows can occur whenever there are water droplets in the air. As the sun's rays hits a water droplet, some of the light is reflected. Some of it is transmitted through the water drop. The transmitted light refracts or bends at the surface of the water droplets. When this refracted light hits the back of the water droplet, some of it is reflected and travels back to the surface again. Here, some of the light is reflected back into the water droplet. The rest is transmitted into the air as it exits the drop. The degree that the light wave is refracted depends upon its frequency, which determines its color. This is why rainbows form the arc of colored bands in the way that they do.